Let's see. Oh, there we go. Okay. I was asked if I would go over some of the problems or something, right? You want me to go over something? Which one? 50. Oh, word problem. Yeah. Yeah, I was going to start class with the word problem from 1-1 because we really only did one word problem. But let's do 57 together and see if we can't figure out, if that doesn't help you with the other word problems that we run into. And then what we're going to do is you're going to get your homework and you're going to pass it to somebody and they're going to grade it, which is kind of weird, but we're going to do that. We're just going to try it out and see how nice y'all are to each other. Okay, you're not going to grade the whole assignment. Just I've picked 3 problems. All right, 57 was not one of them. Okay, 57, sales commission. One employee of a computer store is paid a base salary of $2,000 a month. Okay, so the base salary is $2,000 per month. So what I'm doing is I'm writing down the pertinent information, right? Plus an 8% commission on all sales over $7,000. Plus 8% on sales over $7,000. How much must the employee sell in 1 month to earn a total of $4,000? What sales must they have to earn $4,000 in a month? All right. All right, so what are we being asked to find? The sales, right? We're trying to find what sales. How much do they need to sell in order to make $4,000, right? So we are going to assign a variable, a letter, to this quantity that we're trying to find. We can use any letter we want. We could use S for sales. We could use X. Anything. I'm going to use X because sometimes people's S's look like they're 5s, so I'm just going to use X, all right? So let's try and come up with some sort of relationship that gives us their sales, all right, or the total money. Let's try and look at this in terms of not trying to get $4,000. Just can you come up with an equation that gives you how much they make per month? All right. So why don't we call it this? How about M for their monthly pay? That's how much they'll make a month. All right. What should that be equal to?
2,000.
So 2,000, just 2,000, right? Because that's a fixed. That you just show up, okay? You show up to work, and they're going to get 2,000 a month, right? So it's 2,000. We call this a fixed cost, or in this case, it's not a cost. It's a fixed income. In other problems, we might call that a fixed cost. We're going to do some word problems today with business, like cost, profit, revenue, and the number that doesn't change ever is called a fixed something, whatever, cost, income. All right, so that's fixed as long as he doesn't get fired. And then plus, right, 8%, right? So 0.08, 0.08. I don't know if you've ever noticed some people write 0.08 and some people write 0.08. These are the same thing. It doesn't matter. The reason why people do this is that by putting a 0 in front, sometimes people, don't see the dot and they just, I don't know, they think it's an 8 or something. Like if it was 0.8, you may not see the dot and you may think it's 8. But if you write 0.8, then you're like, wait a minute, what's that 0 doing out there? And then you notice the point here. That's the only reason. It's the same thing. I've always done it this way, so I hope that's okay. All right, what's next? Where's my... Well, I'm only going to here today. All right, so I need to move this over a little bit because I'm off camera. M is 2,000 plus 8%, and this is the part that I think really trips up most people. It's 8% of their total sales? No, it's anything over 7,000. So they're going to get $2,000 a month, and then they're going to sell stuff. We don't know what they're selling, right? Well, does it say? No, it doesn't say what they're selling. Let's say they're selling, what? We'll keep it legit, okay? Let's say they're selling phones, all right? Cell phones, stolen cell phones. We'll still keep a little bit of criminal mind in there. They're selling cell phones, right? So if they sell $2,000 worth of cell phones, how much are they going to make? If they make sell $2,000 worth of cell phones, they're still going to make $2,000. What if they sell $5,000 worth of cell phones? Still going to make $2,000. They've got to actually break 7,000 to start making more money, right? And that's the tricky part of the problem. How do we actually express that in our formula? So let me ask you this. What if they sell $8,000 worth of cell phones? They'll make 8% of what? 1,000. Of 1,000, right? What if they sell $10,000 worth of cell phones? They'll make 8% of 3,000. What are you doing to get that 1,000, that 3,000? You're subtracting, right? You're subtracting this from their sales. So watch me write this first, and then maybe it'll make sense. X minus 7,000. There we go. Now, X here is the sales. And of course, M is the monthly income. Just so we're clear. All right. So does this make sense? If they sell $7,000 worth of phones, 7,000, take away 7,000, 0. Then they're still going to make their 2,000, right? But if they sell $8,000 worth of cell phones, 8,000 minus 7,000, that's 1,000. They'll make 8% of the 1,000. Do y'all see how that formula accounts for that 7,000 that you have to take out kind of at the beginning? That's it. Does that clarify that? Now, we haven't answered the question. The question is, how much do they need to sell to earn 4,000 in a month? Yes?
32,000.
So how do you do that? How did you get that?
I took 2,000 and divided that by 0.08 and then added 7,000.
Where did you put the 4,000? Did you use the 4,000? You should have used the 4,000. Because you want to know how much they need to sell to make $4,000, right? That's what the problem says.
So replace that out with 4,000.
Yeah, so we're going to replace one of these letters with 4,000. It's saying how much do they need to sell, right? How much do their sales need to be in order to make 4,000? So now take your kind of master equation here and replace the M with 4,000. So if I want to make $4,000, then that's the equation I'm trying to solve. And now you're back to a linear equation in one variable. So you'll distribute. So let's see what happens. Got to clear out these parentheses first. 0.08x minus, what's 0.08 times 7,000? So I'm distributing, right? 560. Now, on the right side of the equation, you combine like terms. Are y'all okay with this? Combine like terms, so you can combine these two numbers together. So you get 4,000 equals 2,560 plus 0.08x.
1440.
Pardon?
1440.
What? Oh, when you subtract. Okay, so now we were trying to isolate this by itself. So let's get this out of here. We subtract, you get 1440 equals 0.08x. And then finally, divide both sides by 0.08, right? And what happens when we take 1440 and divide by 0.08? Please, not all at one time, please. Raise your hand.
Right now, the term, like the 2005-16 is supposed to be 1440.
What's 1440? Oh, I subtract, oh. Okay. Oh my goodness. All right. Y'all were all looking at me like I'm crazy, and it's because I look crazy up here. All right, so I added, didn't I? Or did some, I don't know what I did, but this minus this is this, that's what you were saying, and then subtract. So what do you get when you subtract there? 2560 equals 0.08x, and now divide through by 0.08. It's going to be a pretty big number, 32,000. So I'm not sure how you got 32,000 without the 4,000, but it might have been kind of a lucky thing that that happened. Because you need the 4,000. If we change this to 5,000, things are going to be different. You should get a different answer. So they've got to sell $32,000 worth of cell phones in a month to make 4,000. Does that seem out of reach? Well, I don't know. Cell phones are about, the nice ones are about $1,000, right? So 32 phones, 32,000, 32 phones in a month? Yeah, maybe. Does this make sense? All right. What else? Anything?
55.
31 and 55. Uh-oh. I can't do 31.
Yeah, 55 was.
55's not on there? Okay. Let's do this. All I want you to do is just pick somebody at your table to swap with. You give them your homework, they give you theirs. All right? And don't be embarrassed, like if your work sucks and you know, your neighbor's going to know that your work sucks, maybe they'll tell you, hey, get it together. I have a daughter who's in high school, who's a freshman right now, and she was telling me that there's this kid in her class who since they've been there, doesn't do anything the teacher says. Teacher says, stand up, class. He doesn't stand up. Get out your spirals, start doing this. He doesn't do it. And she's like, man, he's such a slacker, right? So she yesterday had to be put into a group with him, and she's like, you know, like, what's your deal? You know, like, are you even going to try? And he tells her, I should probably mute this. Of his, like, you know, why he's such a slacker changed, right? So you never know what someone else is going through. So if your neighbors doesn't have their homework or their homework doesn't look good, I mean, don't judge. I mean, maybe they're just going through something tough right now. And that brings me to the point of if you are going through something and it's hard, your life is hard right now, I recommend that you communicate with me. Because I can handle life getting in the way. What you can't do in college is just be a complete slacker. All right? If you're just slacking, then, you know, hey, college may not be the thing for you right now. You ready? Okay, everyone swap? Everyone find someone to swap with? Okay, so I want you to try and find on their work number 17, number 19, and number 31. These were picked before anyone asked me any questions, so 17, 19, and 31. I'm going to give you the answers. Hold on. 17, 19, and 31. You ready? I'm just going to put the answers up here. The answer to 17 is x equals 10. The answer to number 19 is y is greater than or equal to 3. Now remember, they could also have written this, 3 is less than or equal to y. Those are both the same. And then for 31 is rather messy. There's a couple of, you know what, let me work through 31. Because I want you to grade 31 based upon what they did. They may have got the wrong answer. But I'm going to do 31 up here. So for 31, you're given capital AX plus BY equals C, and you're asked to solve for Y. So you're trying to get this Y by itself. So what we're going to do is we're going to isolate this term by first moving AX to the other side. That means subtracting it on both sides. So it should be BY equals C minus AX. And then at this point, to get y by itself, all you have to do, since this is multiplication, is divide both sides by b. So if you divide the left side by b and divide the right side by b, the b's cancel here. And you're going to have maybe a couple of different ways that this could look. You can have y equals c minus ax over b, like that. Or they could have maybe split it into two fractions and wrote y equals c over b minus ax over b. Either one of these will work. So what I want you to do is I want you to assign to your neighbor a grade. And let's do it this way. Everybody gets 10 points just for being, like, giving your neighbor something, all right? So everyone gets 10. So each problem is worth 30 points each. So if you think they deserve nothing, which would be kind of cruel, then do minus 30. If you think it's, half right, they showed some work, whatever, minus 15. I'm going to let you, it's very subjective here, all right? But I want you to grade your neighbors. Now don't give each other hundreds just like a little side deal y'all are making, okay? I mean, be fair to each other and be ethical, I guess. And just write it anywhere on that page on the top. Were there any questions over those two problems? Any questions over those two problems? Okay. Y'all got it? Now go ahead and give them back. I'm going to pass around the sign-in sheet. And what I want you to do is I want you to look at the grade that you were given. And then I want you to assess yourself. And I want you to you give yourself the grade and you write your grade on here. So if the person who graded it gave you a 60, but you think that you deserve a 70, then you give yourself a 70. All right? This is very loose. Okay? If you feel like, this is one of those things where my dad has this plaque. I always remember this plaque he has in his room. It's right above his dresser. It says, your only obligation in life is to be true to yourself. Okay, which means you have to look at yourself in the mirror every morning. Don't give yourself a 90 if you know inside it's a 30, Okay, that's it. So you do not need to initial. All you need to do is write your grade in there. Okay, understand? All right. I'm going to count that as a quiz grade. All your quizzes won't be like this, all right? Homework is not collected. But if I get a feeling that people aren't doing it, then we'll just continue to do this where I collect it and grade like 2 or 3 problems, where I grade them. So just do your homework. That's one of the most important things for any math class. All right, we're going to move on. The review. Yeah, you know what? When you leave class, well, you know what? Let's just pass them up because everyone might forget. Just kind of pass them, get them all at a table, and just kind of make them all appear at this table somehow. Okay, this is a math for business class, right? And so I want to point out a couple of things that are in the book, but I'm kind of presented a little bit different. Some terms that you'll hear me using, thank you. Some terms you'll hear me using the rest of the way, okay? And this will even extend into the next business class that comes after this, business calculus. Revenue, cost, and profit. You got it? Okay, right here. Any others? Revenue, cost, and profit. Thank you. All right, so when you hear these three terms, most people do not have a problem with the cost, but they confuse what revenue and profit are. So I'm going to do this with a picture, all right? And let's use the company Apple. Oh, I did this last class. How many of, and you don't have to tell me this, but I'm curious to know, how many of you have iPhones? Okay. How many of you do not have iPhones? Okay, that's what I expected. My last class that I taught last semester, it was 100% iPhones, except for me. I was the only one with an Android. All right, so Apple is about to release a new phone, right? iPhone something, 8? 8? Okay. All right, so you've got the company Apple, right? And then you've got the people that are sitting there with pitchforks and torches. Give us new phones, right? We want new phones. And then you've got all the workers over here. Okay, so, well, you know what? We'll make this the building. This is a building. There's smoke coming out of the pipes at the top of the building because I don't know what they do to make iPhones, but it requires smoke at some point. And so when Apple is making phones, right, they have to have electricity, right? They have to pay their employees. They have lots of cost, right? The people who design the phones, the research and development teams. So there's a lot of money that goes into making an iPhone. That's the cost for the company, right? The cost. So the cost is the money needed to make phones. I'm going to say to make the product, whatever it is, whatever you're providing. Then you have revenue. Okay, revenue. So these people are all sitting here with their money, right? Waiting to buy their iPhones. And the money comes in, right? The money comes into Apple. They buy their phones. That's revenue. This is the money coming in to the company. And then the profit would be what? The profit would be what? Pardon me?
After they cover the cost.
Yeah, the profit would be after you take this money in and then you pay all these bills, how much you have left, right? So revenue is just all the money that comes in. Then you have to subtract the cost from it to get your profit. So profit is always equal to revenue minus cost. Or we'll write it this way, P equals R minus C. That's kind of the master equation that we have with business models. Your profit is your revenue minus your cost. Now, with most business applications, there's something called the break-even point. What do you think that break-even point is?
There's no profit?
There's no profit, right?
The cost of the same?
The revenue and the costs are the same. So look, if break-even point is when profit is nothing. You're not losing money, but you're not making money. You're just showing up and doing your job and you're not making any money. That's not a good thing, but it's good to know where that point is, all right? So the break-even point is when profit equals 0. In other words, when revenue equals cost. Do y'all see that if I turn that into a 0? Turn that into a 0? Then add C to both sides, I get revenue and cost are equal? Okay, so that's our break-even point. Revenue equals costs. So let's talk about businesses like Apple. I mean, we don't know for sure, but let's try and logically understand what's going on here. The new iPhone 8's coming out, and let's say that they think there's going to be 1 million people here that want the new iPhone. They think, all right? Are they going to make exactly 1 million phones? No, they're not. What Apple's going to try and do is they're going to try and find this point. There's a point at which if they make too many phones, it's going to cost a lot of money to make the phones, and they're not going to be purchased. And if they have too many phones, the cost of the phones go down. It's like gas. We all had to deal with this last weekend, right? Supply and demand. If they make the new iPhone 8 and they make 10 of them, right? Do you think they're going to sell for $1,000 each? No, they'll probably sell for, right? If they came out with a new phone and said, hey, look, this is our new phone. We're not going to come up with another one for another year. We made 10 of them. It's probably the highest bidders, right? Whoever wants them, highest bidder. So if they don't make enough, the price goes up. If they make too many, the price comes down. So there's this constant balancing act with businesses of trying to figure out that perfect number of things to produce where they can sell it at a high enough cost to make money, but not overproduce something where their costs here get too high. Understand? So the break-even point is important when you're analyzing the business model, because once you find when this happens, you kind of want to stay on one side of it. You don't want to go past the break-even where you start losing money. You want to find the optimal solution. Now, that's why you take business calculus. Business calculus gives you a way to actually figure out where your highest profit will be, the maximum profit. All right, so let's do an example here. This is out of the book You have a multimedia company. This is page 9, example 9, if you're following along in your book. You don't have to bring your book to class every single day, but it's nice if at least one person at the table has it. It says a multimedia company produces DVDs. Let's change that to Blu-ray. Do people use Blu-ray?
No.
Is that? Let's stick with DVDs then. Okay, so a multimedia company produces DVDs. One-time fixed costs for a particular DVD are $48,000. So this DVD company is about to manufacture a bunch of DVDs of the Titanic, right? We talked about the Titanic. We love that movie. We love Leonardo DiCaprio sinking at the end of the movie, right? So it's going to cost them $48,000 to produce this DVD and send it out to the people, which include costs such as film editing, promotion, blah, blah, blah. Variable costs, so I'm going to say this is our fixed cost. Variable cost amount to $12.40 per DVD. And include manufacturing, packaging, and distribution costs for each DVD actually sold at to a retailer. The DVD is sold to retail outlets for $17.40 each. You can probably find Titanic for cheaper than that. But who buys DVDs anymore? How many DVDs must be manufactured and sold in order for the company to break even? All right. Break even would be profit is zero, right? We need to figure out revenue and cost, right? Revenue and cost. And we want to see when those are the same. So looking at this information, does this look like your revenue or your cost for this company? This is your cost, right? So let's try and come up with a cost equation. The cost to manufacture the Titanic DVD is going to be what for this company? $48,000. They've got to fire up the machines, hire the people, pay the electric bill, right? That's fixed. No matter what, to produce any DVD, it's going to cost them $48,000. Plus a variable cost, which is $12.40 for each DVD they make. So I can use X, right? So let's do $12.40 X. Now let's be clear. X equals the number of DVDs made. So if they make no DVDs, it's going to cost them $48,000. If they make one DVD, it's going to be $48,012.40, right? So you just keep adjusting this X depending on how many you make, right? That's our cost. Now, what about revenue? What's their income going to come from? How many they sell, right? Now, what we are going to assume here is that every single one of these they make, they sell. So this should be our revenue function. Our revenue will be how much? $17.40 X. They will make $17.40 for every DVD they make. Now this is not an accurate model of the real world because they may manufacture 100,000 DVDs, but they're not going to sell them all, right? These are eventually going to wind up in some cardboard bin in Walmart for $1.50, right? So the model gets more complicated later, but this is the very beginning of this class, so we deal with a basic model here. All right, understand cost revenue? And now what we need to do is, it says, just so we understand the wording, how many DVDs must be manufactured and sold in order for the company to break even? To break even. So that means I want to set these equal to each other, right? I want revenue and cost to be the same. So I want revenue to be equal to cost, which means I set 1740x equal to 48,000 plus 1240x. And then I solve this linear equation, right? This is a linear equation in one variable. So I'm going to isolate x. So I'm going to move things around and divide through. So let's go ahead and do that. What do we do first? Subtract 1240 on both sides. So what happens if you subtract 1240 on both sides? 5x equals 48,000. So I didn't show that step. I just verbally said I subtracted 1240x on both sides. And now divide through by 5. And what do we get? 9,600. They're going to need to sell 9,600 DVDs of the Titanic, which I'm sure is going to be super easy to do because everybody loves that movie, right? Never seen it?
It's ice.
I'm kidding. I don't like the movie. I mean, I like the end. That sounds really bad, doesn't it? I like the end as an analogy of don't let your classmates sink, like help them out. I'm not saying I like the fact that a bunch of people went down with a ship, but okay. All right, let's move on. 1.2, graphs and lines. So if I were to ask you on a quiz, describe to me or explain to me in words what the break-even point is, what would you say?
No profit.
No profit, revenue equals cost, something like that. 1.2, graphs and lines. All right. To do graphs and lines, what we're looking at here are equations, linear equations in two variables. I'm going to give you some examples of linear equations in two variables first. So as an example, example 1, 3x minus 6y equals 18. This is a linear equation in two variables. How do we know it's linear? X and y, well that's actually, the x and y is why it's two variables, right? But why is it a linear equation in two variables? They're both to the first power. Neither one of these variables are squared, right? So it's linear, two variables, and it's an equation because of the equal sign, right? How about this? Is that a linear equation in two variables? Equation, two variables, both raised to the first power. That is a linear equation in two variables. Two variables?
Yes.
Two variables. Linear? No, because this is squared, right? This is not a linear equation in two variables. All right, anytime we have a linear equation in two variables, it can be written in what's called standard form. Standard form looks like this. AX plus BY equals C. Here, A, B, and C are numbers. So for example, in this first example right here, can you all see that this is in standard form? What's A for this? 3. B is negative 6. Just the number. Just the number. And then C is 18. All right? So these are what we call the coefficients. All right? It's the number in front of the variables. Is this one written in standard form?
Yes. No.
Not the way it's written, right? How could you make this look like this? You would have to bring the y to the left and the 7 to the right. So that means I would subtract y on both sides and add 7 on both sides, wouldn't I? Let me go ahead and rewrite that one just to see what it would look like if I tried to write it in standard form. 3/4 x, then what? Minus y, and then equals 7. So look, I'm not showing these steps, right? I'm doing them mentally. So I'm trusting that you're comfortable moving things around on equations. So now this is in standard form. What's A? 3/4. What's B? -1, right? Because there's a 1 right here. -1, and then C is 7. All right? So every linear equation in two variables can be written in standard form. All right. So let's now take a look at, whoa, what was that? Solutions to linear equations in two variables. So let's take that example. What was that first one I did? It was 3x minus 6y equals 18. Okay. So in chapter 1, section 1, which is what we were doing before, we were solving linear equations in one variable, and we were getting an answer. Weren't we? Like x equals 10 was the one on the quiz problem, the first one that we did, x is 10. Here, because we have two variables, you can't ever get just one answer like x equals 10, because y matters also, right? So when we look at this, I'd like you to see if you can just visually look at that and give me an x and a y that would satisfy that equation. So give me a value of x that I could plug in here, and then a value of y that would make this true, that would equal 18 after you plugged it in. X is up, negative, up. I'm not sure that's going to work. I like 6. I'll go with 6 for x. But if you plug in 6 for x, what's this? 18, and you need it to be 18, right? So that means this needs to be 0. So just how about y is 0? Would that work? Is that the only answer? No? Okay. What's another answer? 8 and 1. Do y'all agree with that? 3 times 8 is 24. Take away 6. Yeah, that'll work. How many answers are there? An infinite amount of answers. And so it's impossible for us to write them all down, right? So what do we do instead of writing out the answers or trying to list them all out for you? What do we do to help us kind of, I'll give you a hint, visualize all the answers? We graph it. And when we graph it, it's going to be a circle? What is it going to be? It's going to be a line, a straight line. So let's see that happen. We have what we call the standard Cartesian plane. I think from our discussions before, everyone was comfortable with this. Is anyone uncomfortable with the Cartesian plane with flat sheet of paper, x, y axes? Everyone knows this point right here is called the origin. Okay? And what we do is we use this to visualize answers to equations. So let's look at this first one, 6, 0. What we do is we write this like this. This is called an ordered pair. It's a pair of numbers, but the order matters. The first number is always the x, and the second number is always the y. So this is always x, and this is always y. So when I write 6, 0, that means you come out here, you go 1, 2, 3, 4, 5, 6. You go out to the right 6, and then on the y-axis, which is up and down, you do not do anything, right? Because it's 0. So you just put a dot here. That dot represents that answer, 6, 0. 8, 1. 7, here's 8. And then 1 would be move up 1, right? Like that. So we had 2 answers here. 2. Let's get one more, but I'm going to force you to get it. I'm going to force you to make x be -2. Then tell me what the y has to be. So think through this. What's 3 times -2? negative 6, right? If I have negative 6 here, I can add it to both sides. What happens if I add 6 to both sides? This becomes 24. So I'm doing this. I'm doing negative 6 minus 6y equals 18. I'm adding 6 to both sides, so negative 6y equals 24. And then dividing by what? Negative 6. And I get negative 4. Negative 4. So y is negative 4. So I'm going to try and draw this here. My x is negative 2. 1, 2. Here's negative 2. And then negative 4. 1, 2, 3, 4. There's negative 4. And it would be a dot here. And what we'll notice is that if we were to continue doing this, okay, if we did, it would be a straight line.
What is the dot do more?
Yeah, why? Thank you. That's 2 mistakes I've made today. It must be Thursday or something. Yeah, negative 2, negative 4. And that's the type of thing I should be taken outside for, you know? All right, so it's a straight line. Now, what we mean is that any other answer that you could come up with, okay, any of them, would be a dot on this line. So all of this solid line really represents a bunch of dots. That's what it is, a bunch of points. And we can be guaranteed that it's a straight line because it's linear, because this is x to the first power, x to the first power. All right? Now, what we're going to do next is I'm going to start off with an equation and I'm going to ask you to graph its solutions. And we're going to come up with a kind of a short way of doing it. I know a lot of you have seen this, I can tell by the look in your eyes. All right, so this example, I want us to graph. Let's try 5x minus 3y equals 15. Now, can anybody tell me what you would need in order to define or to graph a line? How many points do you need?
At least 30.
2. 2 points, give me a point. Another point, there's only one line going through the 2. So anytime we want to graph a line, one way we could do it is just by finding any 2 points on it, right? And you could do that by just looking and trying to plug things in, right? Like just think of something. But we use an even shorter, not a shorter method, but kind of like a rule of thumb, kind of, we always try this. We try and find the points that hit the x-axis and the y-axis. This point right here is called the X-Intercept. I'm going to put X-INT, but that's intercept. And then this one right here is called the Y-Intercept. I didn't write intercept here because the camera is going to cut it off. So X-Intercept, Y-Intercept. On this problem, did we find the X-Intercept? Yes. I mean, we see it. The Y-Intercept, we never found that, right? Because we just like randomly plugged in points. But there is a way, given a linear equation, 2 variables, there is a way that you can try and find the X and Y intercepts. So how do we find the X-Intercept? Anyone know how you would find the X-Intercept on a graph? Set the Y equal to 0. Set Y equal to 0 and solve for X. I'm going to put a star next to this. That's how we always find X-intercepts. Whether it be a line or a parabola later or some crazy trig function in pre-calculus. It doesn't matter. If you want X-intercepts, you set the Y equal to 0. All right? So let's rewrite this equation and let's replace Y with 0. 5x minus 3 times 0 equals 15. Just remember, to find X-intercepts, you set Y to 0, not X. It's the opposite of what you think. And what does that give you here? 5x is 15. So X is what? 3. So written as an ordered pair, what would the ordered pair be for that point? 3 is the x, so 3. And then what about the y? It was 0, right? Because we set it equal to 0. So 3, 0. So I'll plot that in just a second. Well, I'll plot it now. I'll plot it now. So 1, 2, 3, 0. There it is. I just need one other point, and I'm in business, right? So now let's find the y-intercept. How do you find the y-intercept? Set x to 0, and then solve for y. So if I rewrite that equation, 5 times 0 minus 3y equals 15, then you get negative 3y is 15. So y is negative 5. Y'all comfortable with that? Any issues there? So what is this as an ordered pair? 0, negative 5. So that means x is 0 means I don't move left or right, and then I move down 5, right? 1, 2, 3, 4, 5. Once I have 2 points, I connect them with a straight line, and I'm done. Pretty straightforward? Any questions? Okay. Now, that example was very, very simple. There were no fractions involved. When you do your homework, I'm sure there will be some fractions. Would you like to see a fraction problem?
Yes.
Yes? You want to see one? Okay, let's get one that the numbers will get a little uglier. So how about 1/2 x minus 5y equals 8. So I'll move a little faster through this one, all right? Linear equation, 2 variables, right? Linear equation, 2 variables. This is a line. So find the x-intercepts. To find the x-intercepts, we set y to 0. So 1/2 x equals 8, right? Because when I set y to 0, it kills this off completely. How are you going to solve that? Multiply both sides by 2, and that will clear out that fraction. So 2 times this, 2 times this. Why? Because I'm trying to get rid of a half, right? You could divide by a half, if you prefer. You get the same result, though. I'm looking at this as 1 over 2, so I'm multiplying it by 2 over 1. 2 over 1. That's what I'm doing. And that way it goes away and you just get x here. And then on this side, 16. So x is 16. So your x-intercept written as an ordered pair is 16, 0. Okay? Now, the y-intercept, you set x to 0, right? And what would happen if you have x to 0? We get cancel out, so negative 5y equals 8. Agreed? Divide by, hello, y'all okay? Negative 5? Okay, so 8 divided by negative 5. So we might want to get a decimal here to help us out. So we get our calculators out if you need it. What is that? Negative 1.6 is your y. So written as an ordered pair, 0, negative 1.6. I have 2 points. Once I have 2 points, I can graph it. Now this graph's going to be a little weird because I've got a point that's way out at 16 and then negative 1.6. We're going to have to kind of eyeball this and do our best, all right? So let me squeeze that in here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 16, 0. And then 0, negative 1.6. So here's negative 1, here's negative 2, right? Negative 1.6 is somewhere in there. Good enough? And then we draw our line through the 2. Whoa. All right, I'm going to ask you to graph another one. What? The heck is that? I don't even see a Y, right? Just a straight, yeah, it's straight, but, okay, yeah, I'm seeing, yes, it's one of the, it's either vertical or horizontal. It's weird. When I was a kid, I had a lot of issues, okay? I still have them, but now I'm an adult, so they're not as obvious. Maybe they're more obvious. I had a real hard time with remembering what was vertical and horizontal. And then someone told me horizontal, like the horizon, and I was like, oh yeah. Okay. Horizon, horizontal, vertical, right? So this is either a vertical line or a horizontal line. So think about this. If you have an equation in 2 variables, and one of the variables is missing, and it's linear, and you're asked to graph the solution, it's either up and down or left and right. Now the way that I think you can remember this is, here's x is 3. 1, 2, 3. Right? That point definitely has to be there, right? Now, if I go up 1 and put a point, what's the x coordinate of that point? 3. It's 3, 1, right? This point right here is the point 3, 0, right? What would be another point, let's say, up here at let's say 9? That'd be 3, 9, right? What do all those points have in common? X is 3, right? X is 3. That's what this equation is saying. Give me all the points where your x coordinate is 3, and that will draw you a vertical line. Now compare that to this one. Let's say y is negative 2. So this is saying to you, give me the line where your y coordinate, right, y is up and down, is always negative 2. So this will be a horizontal line, correct? Here's negative 2. It's that point, this point, this point, all these points. Make sense? Horizon. Nobody ever believes this, but this is a true story. You know the months of the year? January, February, March. I did not learn those in order, okay? I knew them, but I didn't know them in order until I was about a sophomore in high school. I remember sitting at a restaurant with my parents, and I was like saying something, and my parents were like, do you know the months of the year in order? And I'm like, I tried to say, I didn't know it. So I think what that means is that I had a really, really good childhood. I think that means that I was just having so much fun as a